Okay. Why is it not saying it's recording? There we go. Okay, so we're continuing on, proving some beautiful theorems about parallelograms. But before we move forward, let's just kind of revisit what we talked about last time and make sure that we're ready to move on. So I'm just going to do this with a blank screen. By all means, you know, you have information in there that you can easily see, but let's just say you're given a parallelogram. And forgive my sketching, it's not the best, but there you go. I'm saying it's a parallelogram. And let me call this A, B, C, and D. So if I have this parallelogram, there are 4 very important properties that we've talked about in particular that would allow us to say, if this is true, then it's a parallelogram. Okay? So if this is just a quadrilateral, let's say, and I want to be able to prove it's a parallelogram, there are 4 things that I should be able to say. Can somebody tell me what one of those things is? The opposite angles, what? Are congruent. So, I mean, when I say opposite angles, what am I looking at? I'm looking at, that's right, these are congruent, and then, okay, so if I can show that, it's a parallelogram. What else? Okay, opposite sides are congruent. So if I can show that AD is congruent to BC, or AB is congruent to CD, I have a parallelogram. What else? Okay, so that wasn't one of the major 4 ones, but that is something that we could show. So I'll go ahead and put that in there, but we're going to have to add another one. So consecutive, oh, my pen. Angles are supplementary, meaning they add up to be 180 degrees. And so that means A and B, if I add those together, excuse me, I'm going to sneeze. They went away. If the sum of angle A and the sum of angle B should be 180, sum of angle B and angle C should be 180, etc. Okay. What else? Oh my gosh, I'm having issues with this. Let me see if I can use this font. But yes, the diagonals bisect each other. That is true. Okay, let's see if this will let me do this simultaneously. I'm not holding my breath, but we'll see. Please, oh please. No, that's pitiful. So what did we say? Diagonals bisect each other. So if I draw my 2 diagonals, I can introduce a new point that would allow me to say that this is congruent to this, and this is congruent to this. What else? Opposite sides are parallel. Okay, so this is parallel to this, and this is parallel. I'm having serious issues with my little pencil, so forgive me. Now, there is something new that we can, yes, yes, yes.
Oh, I was just wondering, there's a line that goes down the middle of the parallel, and there are angles. alternate interior angles.
Okay, so I need to see a picture. So you're saying if I drop from here or from where?
From like the bottom left side to the top right side.
Bottom left side, where?
To the top right side.
Yeah, so that's a diagonal. And if these are parallel, then these alternate interior angles are congruent. Yes, you are absolutely correct. You are absolutely correct. No, but if I have these two and I know they're parallel, oh my gosh, right? And I draw a transversal.
Yeah, but how do you prove the other side?
Actually, I
We
can.
need both instead of the the other sides are parallel. Yeah, you did a
Yeah.
transversal both ways.
Also,
Yeah, so then I also have this.
Also, you can just add up the two angles. And
Yes.
triangles.
Yes. Yes, absolutely. So there's lots of pieces, but the point is if I have any one of these that I can show, then that is sufficient in saying that it is a parallelogram, right? So we wouldn't need, all these components to be true. We just need one of them to be true for it to prove it's a parallelogram, okay? So the first page in your notes actually is demonstrating this. So we could go through this, but this separated it into different little quadrilaterals, showing the different pieces that I would have to show. Now, this one's new. This is something new. If I have two opposite sides, oh my goodness gracious, this is going to drive me crazy. If two opposite sides, one pair, are both congruent and parallel, then the quadrilateral is a parallelogram. So instead of saying both pairs are congruent, both pairs are parallel, if I just have one pair that is both parallel and congruent, that is enough to show that the quadrilateral is a parallelogram. So let's look at a few examples and let's see which of the given quadrilaterals are parallelograms, and then let's go one step further and talk about how we know it to be true. So if I have this upper left-hand example, is this a parallelogram? And if it is, how do you know? So is it a parallelogram? Looking at this information. Yes. And both pairs of both opposite sides are parallel, right? If this lets me write. Okay.
What do you mean both?
So if I have this and this being parallel, this is cut by a transversal, I can look at my alternate interior angles. This is definitely needs charging. This one and this one. Okay, then if I look at another set cut by that same transversal, right? I have another set of alternate interior angles, don't I? So since I've been given so many degree measures, I know that both pairs are parallel, don't I? Stop me if you don't understand or don't agree. Okay, looking at the next example, is this quadrilateral a parallelogram? If so, how do you know? This one. Yes. All right. This is congruent to this. This is congruent to this. Okay, what about the next quadrilateral? Is it a parallelogram? And how do you know? Okay, there's a couple different.
Because the opposites.
Yes.
And the consecutive.
Right. Beautiful. The consecutive angles add up to be 180 degrees. And then we can find this missing angle by a couple of different things, right? If these turn out to be parallel, then we know that the alternate interior angles will be the same. But we also know the sum of the interior angles equals what? Of all 360. So we could add the 3 that we have, subtract from 360, and see that this one is in fact 106 degrees. Yep. Okay, let's try more examples. Looking at this example, upper left-hand corner, is it a parallelogram? And if so, how do you know?
The intersection
Yes, the diagonals, right, bisect each other. Mm-hmm. So in other words, this is congruent to that, this is congruent to that, and those are diagonals and they bisect each other. Okay, what about the next example? Is that quadrilateral a parallelogram? And how do you know?
Opposite sides are, opposite angles are.
Okay, how are we finding the degree measure here? Subtract it from 180, right? Okay, so what is the degree measure just for kicks of this angle? Yes, and so do I know the degree measure here? Absolutely, it's 117. So opposite, well, we know the opposite sides are also congruent, right? And what about the last example? Is that quadrilateral a parallelogram?
the opposite sides are
Yes. And what? Yes, they are parallel. You know they're parallel because of the alternate interior angles. And so if those two are the same, these, I mean, do you see? There's so many things that you know when you're, these are little puzzles. They're so much fun. I mean, my gosh, it's just screaming at sine angle side to prove it. I mean, just so many things. So yes. All right, there's another theorem, and we're going to go ahead and prove this next theorem. So let me highlight it. If both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. If both pairs of opposite sides, so we've seen this before, but let's go ahead and prove it. So you've been given some information. You've been given that TS is congruent to QR. So TS is congruent to QR. So that's a given. You've been also given the fact that TQ is congruent to SR. So that's been given. Now, you've been told to go ahead. They're giving you a hint. They're saying, go ahead and draw QS, the line segment QS. So let's draw the line segment QS. And that happens to be a diagonal, right? And what is the reasoning? How can we write that QS? What allows us to draw that line segment? Beautiful. Because through any 2 points, there exists one line. Now, we just drew that QS, so what can we say about QS? That's right. So QS is congruent or equal to QS. And what allows us to say that? Yes. Now, look what we have. By drawing that diagonal, we now see what? What do you see? Okay, so I see two triangles, right, that are congruent. I have this triangle is congruent to this triangle because of the reason you just said, side, side, side. So I'm going to say triangle QTS is congruent to triangle SRQ. And of course, once you can prove that two triangles are congruent, then what do we know? We have a whole lot, right? But once we prove two congruent, yes. So let's be a little bit more specific. By CPCTC, we can say that angle TQS is congruent to what? Angle TQS. So this angle is congruent to what? Yes. Excellent. Okay. Now, there's kind of two more pieces to this. So if I am looking at these congruent triangles and I'm looking at their corresponding parts, then what do I know perhaps about other pieces of these triangles? Like perhaps maybe I'll give you a hint. What if I look at TQ? What can I say about TQ? Okay, it is congruent to SR. Oh, that is a given. Yeah. What else can I say about TQ? Yes. To what? Yes. So these are not only congruent, they're parallel. And if they're parallel, how do we know that? The alternate interior angles imply the lines are parallel. Now, we went ahead through that, the fact that those two triangles were congruent to show that these alternate interior angles were congruent. Yes?
States that
yes, we're gonna do exhaust all the pieces. Yeah, yeah. We after this right here, absolutely.
So wait, could we have done it like on this graph?
Yes, right here. but we're trying to prove it's a parallelogram. So we worked with one set of alternate interior angles. Do we want to say anything about any other ones? Okay, so now maybe I'm looking at these, right? So maybe TSQ is congruent to SQR. And how do we know? CPCTC, right? Because they're parts of the congruent triangles that we just showed. And then similarly, just like we proved TQ and SR were parallel, can we say something else about the other pair of alternate sides, opposite sides? We can say that TS is what? Yes. And again, by alternate interior angles. Imply parallel lines. Now, could we have combined some of these things? Yes. Could we have combined the givens? Yes. Could we have combined the alternate interior angles and shown CPCTC for two sets? Yes. Could we have combined these? Yes. But we're just putting them all in separate lines. Okay? So last but not least, the whole point of this was to prove oh heavens, I wanted orange. This, and we have now proven it because we have all those little pieces that we needed. And how can we justify this? The definition of a parallelogram. Opposite sides are parallel in particular.
Wait,
Mm-hmm.
why couldn't you do the one we just did earlier if two opposite sides are both congruent and parallel? Because we have them.
You can.
Oh,
You absolutely can. Yes, absolutely.
if I only use the first two steps,
Well, but we're not really just proving that the two opposite sides are parallel or just that the two opposite sides are congruent. If that was the thing you were trying to prove, then you could stop. If we're trying to define that it's a parallelogram, we want to show all the things that we have said are true. Does that make sense? So if it were just to show that they're parallel, you could stop. Or if they're just to show that they're congruent, you could stop. Or if you were just showing that the alternate interior angles were congruent, you could stop, right? Because that would show that piece of it. But if we're trying to prove the definition of a parallelogram, then we want to show all of those things are true.
You also, like, the path of, or if you want to take instead of doing like the alt interior angle, you do like angle addition and show that like the angles is like the opposite angles of each side.
Yeah. Mm-hmm. Yeah. I mean, again, there's not just one clean proof. You can expand and contract on these. All right. The next one is kind of along the same lines. So I want to see if you can do this one and then I'll go through it. So go ahead and see if we can follow that same path and do the proof for this one. And then I will give you the steps. We're emulating what we just did. So try it and then we'll go through it. And then we'll do one more proof and then I'll give you time to work on the homework.
When is the homework due tomorrow? It's due
Thursday. Yeah. Tomorrow we're going to do 2 activities for participation points. So they'll each be worth 5 points. Mhm.
But do we have a quiz tomorrow?
No, I changed it. It's
Oh.
not a quiz, and it's just two activities now for participation. So yes, as you notice, things are very, very fluid and subject to change, but I do post all those changes on Canvas, so you will be able to see that. Thank you for noticing that. So we're trying to prove this, and then we will go through it. And you're kind of emulating what we just did on the last one. And then at the bottom of the page, you see those beautiful 5 things. And those 5 things, again, you only have to prove one of them to prove that it's a parallelogram. If you think you got it, feel free to try the next one. But we will do the next one together as well. Your fingernails match your highlighter. How cute is that? Do we need more time on this one?
Yeah.
Yes? Okay. Not going to rush you. Again, if you think you got this one, feel free to try the next one, but we will do the next one together as well. And we're covering our notes. Cover our notes. Are y'all ready to go over it? Yeah? Okay. Okay, so obviously, look at those first two lines. They're just like the last one. They gave us that information. So these two are given. So I like to label it in my picture. So TS is congruent to QR. That's the first one. The second one is saying that TS is parallel to QR. They told us the next step was to draw TR. So I'm going to draw TR. We know this why? Because? Now, kind of similar to the last one, what would you state next? Yes. By what property? Okay. And what would you show next? Okay, do I know that?
No.
Not yet?
Oh, wait.
Since they're parallel, what do I know? Yes. STR is, that angle is congruent to TRQ because of alternate interior angles being congruent because of the parallel lines, right? Yes.
Couldn't it also have been TRQ?
Yes. TRQ, that angle, yes. Yeah, that's the second piece. Absolutely. Absolutely. So now that we have these angles, STR is congruent to TRQ, I have side, angle, side, right? And so I can say based on that, that those two triangles are congruent. Triangle QRT is congruent to triangle STR. And since those triangles are congruent, I have more corresponding parts that are congruent, right? I have angle QTR is congruent to angle SRT, just like you said. Do we have other information now? What about them? I know they're parallel, right? Again, because of those alternate interior angles being congruent because of the parallel lines. And that brings us to our final fact that we are trying to prove is that this quadrilateral, oops, if I can. I was right there with you a minute ago. Okay, yes.
I did two different things.
What did you do?
For 7, I did TQ's parallel to be congruent to SR, and I just said CPC.
We do know that. Yes. Yes, yes, yes. Yes, yes, yes.
And for 8, I instead said that TQR is congruent to RSP.
And how did you say that? How do you know that?
CPC.
Yes. Yes. That's valid as well. Of course. Just sneeze already. Mine went away completely. Okay, so again, there are 5 different ways to prove that a quadrilateral is a parallelogram. You only need to show one to prove that it's a parallelogram. All right, let's look at another theorem and let's prove it. If the diagonals of the quadrilateral bisect each other, then we said that it was, in fact, a parallelogram. Now, again, like we did with the little patty paper, we could draw it, we could fold it along the diagonals, and we could see, right, that they bisect each other because those sides are the same length. But let's talk about how to classically prove this. So we have some information that is given. I see that RT bisects SQ. Okay, so that is given. So let's look in this, and I see RT bisects SQ. So SQ is now bisected. So if I've bisected SQ, then I know those two pieces are congruent, right? What else? Well, I have another given. I might as well use it. SQ bisects RT. So SQ.
I think if you already have that.
Actually, yeah.
I have a question.
Yes, ma'am.
So, on the book that this one, why is there not like a line where you should put that like X is in the middle of like is the point in between those?
You could define the point.
Because, like,
You could define a point and you could use it. Absolutely. In fact, let's go ahead and do that.
But shouldn't that be before, like, wouldn't like line 2 be like,
We have to introduce the point so that we can state that those segments by defining those segments, which we would need that point. You are absolutely correct. So let's go ahead and define that. I don't care what you call it. V for vertex. So now I need to, based on the fact that we drew in the picture that those two segments are congruent, let's define them. So I can define SV being congruent to what? And that's by the definition of the segment bisector.
you need to add a line that like V because between two intersecting lines is not exactly one point.
Between two intersecting lines. No, you don't have to define it.
You don't have to define it in the proof.
No.
You can draw it.
Yeah. I'm okay with that. Okay. Although that would be nice, but no, you don't have to do that. Okay, so we have SQ bisects RT. So if SQ bisects RT, then these two pieces are congruent, right? So this was a given. And I can say what two line segments are congruent?
TV and RD.
Yes. Same definition. Now we're ultimately trying to show that some triangles are congruent, right? Does anybody see any vertical angles? I do. What vertical angles do you see? Yes. And what can you say about those vertical angles? Yes. So TBS, let me, is congruent to this. And now that we have those two line segments and those angles, what can we say? Yes. So we have triangle TVS is congruent to triangle RVQ by what? Yes. So this is congruent to this. And of course, once we have triangles are congruent, what do we know? The sides are congruent, angles. Yes, we have a lot of stuff going on. So of course, now let's look at some corresponding parts of these congruent triangles. Maybe angle VTS is congruent to QRV. Let's see what else we have. We have, well, if we know that, oh my gosh, look at those lovely little alternate interior angles, right? Do we see alternate interior angles? So that means we have two, yeah, we have two parallel line segments. Okay, so since those alternate interior angles are congruent, we have TS is parallel to QR. But not only are they parallel, what else do I know? Yeah. Mm-hmm. CPCTC. And we have enough to show this. It is, in fact, a parallelogram because opposite sides are congruent and parallel.
And would it be definition of
Oh, yeah, that is part of the definition. Yep, you got it. I just was a little bit more explicit. Yep, absolutely. Okay, so your homework. You have some problems in the book, but you also have a little worksheet, right? So what I would like you to do is I would like you to work on the worksheet first in class, because as you complete those, let's say we all finish the first one, I'm happy to go over the answer to the first one. If you finish the second one, I'm happy to go over the answer to the second one. So let's do that first. You have about 25 minutes, so we really could get through those two. On the worksheet. So you have 4 on the worksheet. Let's do the first 2. So we're working on this. Part of your homework. Let's do that one first. So it's in your packet, or it should be in the homework packet. Do you see it? Okay, so let's do that first. Now, look how lucky you've been given all of the facts, right? You just have to provide the justification. That's lovely. So let's go through that. And then I'm happy to go through the answers. I like to go through the givens first. So try those. Provide the justification. Oh, and another thing, as you turn in your homeworks before you scan them, make sure your period is on there, because I only teach the 6th period. And so I want to make sure I'm grading only y'all's paper and not other teachers, because that would not be appropriate.
I don't see that thing. I don't know. I printed this like so
The homework packet.
here. There you go. There you go.
Okay, so we're providing the justification for the first 2, and then we will go over it.
What is the shape on number 2? Oh, it's not 2D.
That's just.
So if you've done A, go ahead and try B. Again, you've been given all of the facts, you just have to provide the justification. Anybody still working on A? No? Okay, let's go over the first one. Okay, so you've been given that ABCD is a parallelogram. So we know a lot just by that statement. But you have also been given the fact that M is the midpoint of AB. So M is the midpoint of AB. So if I know that, then I know these two are congruent. Right? Now, I've also been given the fact that N is the midpoint of DC. So if N is the midpoint of DC, I know these two are congruent as well to each other. Okay? So that's just from the information. Now, since ABCD is a parallelogram, I know a lot about it, but how do I know that NC is parallel to AM? How do I know that? Yeah, by the fact that we were given that these are pieces of the definition of the parallelogram. So these are pieces of that bigger parallelogram. So I know by the definition of the fact that ABCD is a parallelogram, those two things are parallel. Now, I also know that DC is congruent to AB. So DC is congruent to AB. So if these two big pieces are congruent, we can look at little subsets of those, right? But I also know that DC, oh, well, they're just telling you the same thing. DC is equal to AB. How do I know that? Yes, opposite sides are congruent. Excellent. Now, this is a blast from the past. How do I know that half of DC equals half of AB? But be more specific, because we're not saying that something is a parallelogram. We're saying that line segments are congruent. So we have to say something about the sides being congruent, right? Does that make sense? Kind of like before, we're not trying to prove, you know, it's a parallelogram. We're trying to prove things that tell us that it's a parallelogram. So since we're specific, we didn't say that the conclusion we're drawing is that it's a parallelogram. The conclusion we're drawing is that those line segments are congruent. So we have to use the fact that opposite sides are congruent to say that those two sides are congruent. Yes? Not quite. Not quite. Because all I've done, if you look at this and you look at this, what have I done to each side? I divided by 2 or multiplied by half, right? So the justification here is just multiplication or division, right? That's all I've done from step 3 to step 4, is I've multiplied each side by half. Now this was given. So now, what are you thinking? Yes, the midpoint theorem. This was given. So the next step is justified by, again, the midpoint theorem. And something very interesting is happening here. So if I look at this, and I look at this, that automatically is going to give me this. But how can I say NC is equal to AM?
Can't you say it opposite?
Substitution. And what are we substituting? If you look here, right? If I take that information, AM is half of AB and NC is half of DC, I can just substitute in what I know about DC here. Half of DC, we said, was NC. Half of AB was AM. So that's half of AB. Do you see how I can just do substitution? And that gives me that AMCN is a parallelogram because we have shown that opposite pairs are congruent and parallel. You want to try the next one? Justification on the next one? I saw everybody labeling the givens first. Did y'all get it already? Yes, you've already justified these? Feel free to do the next one. C and D. If you haven't finished, if you've already finished B, go ahead and do C and D. That's part of your homework. The rest of you keep working on B.
I have a question for most of these, like the last phrasing, isn't it usually this definition of parallelogram, or are we just supposed to be more specific?
I would be more specific and look at what you've shown in your proof. If you've shown that two sides are parallel and congruent, that is a definition, a component of being, a parallelogram. But I would be explicit and say what you have shown. Okay, shall we talk about the justification for these? Okay, how do we know that AD is parallel to BC? Yes, the definition of a parallelogram. And so since AD is parallel to BC, and I see that AC, then how can we say that angle DAE is congruent to angle BCF? Okay. Well, not alternate interior, right? Opposite sides. I mean, well, no. You're right for that. Alternate interior angles. Because parallel. Yes. And how do we know that AD is congruent to BC? AD is congruent to BC. Okay, so because of their being parallel, the opposite sides are congruent. And then we have two givens. And how do we know that DE is parallel to BF?
You want the parallel to the same line.
Okay. So in a plane, are perpendicular. It's the same line, then parallel. And DEA and BFC are right angles. Yes. Definition of perpendicular. And how about DEA and angle BFC? How do we know those are congruent? Beautiful. Right angles are congruent. And then triangle DAE is congruent to triangle BCF. Excellent. Angle, side. And then DE is congruent to BF as a result of the congruent triangles. The corresponding parts are congruent. CPCTC. And last but not least, DEBF is a parallelogram because we have shown that opposite pairs are congruent and parallel. Okay, so you have bookwork in the rest of the packet and you have the worksheet to complete. You're scanning all of that and uploading it to the homework for 5.2. Remember, do it in the packet, scan a single PDF, make sure that your period is on there. Yes, sir.
What is the reason for number 3? Sorry, number 10. Number 10.
The number 3, alternate interior angles are congruent because the lines are parallel.
When do you usually put up the answer key for homework?
After class. So I graded them right before class. I mean, like right before, as you were walking in, right after first after advisory, as you were walking in. So I will post those today.
Okay, usually Dr. Fullerton waits a couple of days. So
well, no, as soon as everybody turned it in, I figured
I was gonna say that's a good thing that you do.
Yeah, no, I'm gonna go as soon as I grade them, which I just did. I'll do it during lunch. Yes. Any questions online? No questions online?